The next thing to talk about are the three ways we can model relationships in nature. We have three different things. We call them pyramids, although they don't have to be pyramidal in shape. So pyramid implies wider at the bottom and then getting narrower towards the top, but that's not always true. So these three types we have are pyramids of energy, numbers, and biomass, and they all look different. A pyramid of energy is the one we were talking about before, where as we go from one level to the next, we only get to keep 10% of the level that we had before. Pyramids of numbers are where you count individual organisms. Pyramids of biomass are where you weigh the organisms. So you do that by, if you're doing pyramid of biomass, you want to find out how much grass. You chop down a bunch of grass, you dry it out, you weigh it. You want to find out how many rabbits. You kill a bunch of rabbits, dry them out, and weigh them. So the three types are pyramids of energy. The pyramid of energy is always, always, always upright, and the word upright means bigger bottom and then getting progressively smaller as we go up. That's because of those laws of thermodynamics we talked about before, where there must be energy losses from one level to the next, because no process is 100% efficient. If we look at pyramids of numbers, we count how many organisms. That could be something like this, where it is pyramidal in shape. We would call it upright. Or it could be not. So if we have something that is a producer that has just one tree supporting a whole bunch of beetles, which support a few woodpeckers, then this would not be pyramidal in shape. So it would go as small, big, and smaller. We could also have the same situation if we had like one whale, and then that's not a one. If we had one whale that was then going to support a whole bunch of things that are eating it after it dies, say a dead whale sinks down to the bottom of the ocean, supports a whole bunch of small, tiny living things, which then support other smaller living things above them. But that bottom layer being smaller than the layers above it would mean not always upright. If we do by biomass, this is almost always in the same shape as a pyramid of energy. That's because we store energy in chemical bonds. We store energy in the bonds between amino acids, or the bonds between sugars, or the bonds between any of our macromolecules. And that results almost always in a pyramid that is big at the bottom, small at the top, in terms of mass of material here compared to mass of material there compared to mass of material there. There are a couple of examples in the world where it seems like this law isn't being followed, but I would wager that there's actually just a problem with measurement, and they are pretty rare anyway. Biomagnification, or bioaccumulation, is talking about when we have individual molecules of things. So a really common example of this is mercury-containing compounds, especially methylated mercury compounds. Those ones are really well absorbed by living things. Pure mercury is not so well absorbed. But when we have molecules of something in the environment, it's in the water, it's in the air, those are, of course, absorbed by, in varying amounts, in varying concentrations, but absorbed by the organisms that are living. So as they're living, they're breathing, or they're otherwise just absorbing things by osmosis or diffusion from their environment. And if those don't get broken down from one trophic level to the next, so as we go from our producers to our primary consumers, secondary, tertiary, quaternary consumers, if they don't get broken down, then they stick around. We call this accumulating, and this process means that the concentration is higher and higher and higher in each trophic level. As we go up each trophic level, that concentration is going to be about 10 times higher per level. Of course, that will vary by the individual organisms. The concept of bioaccumulation or biomagnification is really important when we have long food chains, especially when we are eating things that are further up the food chain. So if we are eating insects, the concept of biomagnification or accumulation doesn't matter much to us. But if we are eating something that eats something that eats something that eats insects, then we are many steps further up this chain, which means that we are much more likely to be affected by bioaccumulation or biomagnification. So if we're eating something like here, this tuna, this is at the time a world record tuna. If we're eating something that has clearly eaten lots of smaller fish, and they have eaten smaller fish, and they have eaten smaller fish, the levels of harmful substances will be higher than they would be in organisms that are at a lower trophic level.